Hi everyone, Kittyman74 here. Well, this channel has gotten a bit more views, but I really hope that you guys can have more comments so I can know what to work on in future and how to improve myself, yeah? Alright, so today I'm going to talk about O-level AMaths. Two questions here, partial fractions and surds, and they are from November 2018, paper 1. So let's get right into it. Okay, let's start from the partial fractions one, yeah? Well, this doesn't look all that hard, but it looks kind of scary, yeah? Because there is this 2x, there's this x squared plus 4, which is a quadratic factor, and also this quadratic expression at the top, and it's worth 6 marks. Normally, if you see a 6-mark partial fraction, right, it's a lot. And normally partial fractions are combined with integration questions. So for it to have a standalone 6 marks really isn't that common. And we'll see. It's kind of tedious, but it's not too difficult. Okay, let's go. So as usual, when you want to have partial fractions, right, always write down this statement first. Okay, let the original question be something. So the correct thing to do is to have this 3, the congruent sign. So because we know this factor, the denominator is very nicely factorized for you already. So the first factor you have here is 2x minus 1, and this one will just be a. And because you know this other factor is a quadratic non-factorizable factor, x squared plus 4 can't be factorized into anything simpler. If it were x squared minus 4, you could break it up into 2 further linear factors, but because it's just x squared plus 4, so it must remain as x squared plus 4, which means on top you have bx plus c. Okay, so then your next step, multiply throughout by 2x minus 1 multiplied by x squared plus 4, so we have this. Okay, then 2x minus 1. So I know different schools teach students different methods. You have things like cover-up rule and comparing coefficients and stuff, right? But for me, my preferred method is actually just letting x be some value, which actually is the basis of cover-up rule. But I prefer explaining it in this way so that students have, in my experience, students understand this a lot better. So I let x equals to half here. So why is it x equals to half and not any other value? So just think about this, right? So if you let 2x minus 1 be equals to 0, x should be equals to half. Okay, so why is this relevant, right? So if when we let x equals to 1, we'll have 7 times 1 quarter minus 6 plus 17 on the left hand side. And then this a factor here will be half square, so 1 quarter. 4 and 1 quarter is 17 over 4. Okay, the interesting here is plus bx plus c multiplied by 2x minus 1. Because we let x equals to half, right? So this entire thing is 0. And we do not have to deal with bx plus c. So put a 0 here. Again, right, the basis of this method, let x equals to half, is because we over at the start we define this fraction is congruent to whatever things that's on the right hand side. That means that whatever value we let x be, the left hand side will be equal to the right hand side. Okay, so if we want a bit more explanation on that, maybe we can do it next time, but for now, the purpose of solving this question, this should be good enough. So I'm going to have 7 over 4 minus 6 plus 17 is plus 11 equals to 17 over 4a, and then a will be a very nice number over here, a equals to 3. Done. So that's your first factor down. Okay, then the next thing we can continue using this idea, right? Let x be equals to 0. Always use simple numbers that are easy to calculate. So left hand side 17, right hand side is just a, 3 times 4, I'm sorry, plus, when we let x be equals to 0, right, we'll just have c multiplied by 0 minus 1, negative 1. So c will be negative 5. That's correct, yep. See, that's how fast you can do it. And finally, when you want to find b, right, just let x be any other number you prefer. So obviously I prefer small numbers, easy to calculate. Let x be equals to 1, 7 minus 12 plus 17. A we know is 3, so 1 plus 4 is 5. Bx plus c, this one will be b plus c is minus 5. And then I'm going to have 2 minus 1 is 1 here. Okay? So 7 minus 12 plus 17, 17 minus 12, 5, 12 equals to 15 plus b minus 5. So b is equals to 2. Is that correct? Yes, that's correct. Now, so we need our concluding statement, right? Remember partial fractions, we always need this final concluding statement. So let's just write this down, everything down, and then you realize that, hey, 6 marks. That wasn't too difficult. So this is equals to 3 over 2x minus 1 plus 2x minus 5 over x squared plus 4. Okay, done, 6 marks. But that wasn't too hard, but if you want an extension to the problem, maybe you just think a bit. Think, okay? What if you replaced x squared plus 4 with x squared minus 4 or x plus 4 squared? How would it change your answer? How would it change your working? Okay, so these are entirely possible. They can be tested in this way, so please try it on your own for practice. Okay, now let's move on to question 4. Question 4 is actually quite interesting, 4a at least. So you're told that this is a root of the equation x squared plus ax plus b equals to 0, where a and b are integers, and they want you to find the value of a and of b. Doesn't sound too difficult, right? But actually, the shorter the question, the harder it is, because the less information you have. Okay, so how should we approach this? Since we are told that this is a root, since 2x plus 5, let me just move the screen down. 2x plus 5 is a root of x squared plus ax plus b equals to 0. Let me just sub it in, okay? Because by definition, right, a root is a value of x that will make the equation 0 anyway. So doing this is perfectly correct. Nothing to be worried about, okay? Then we're going to square this. Okay, then now, well, let's just continue expanding and see where we go from here, okay? So 9a plus b square, right? So 9 plus, when you square this, 2ab, I would get 4 times 3, 12 square root 5, plus 4 times 5, right? So it's 20. So be careful with the square here, okay? 2 square root 5 when you square it, 2 square is 4. Square root 5 when you square it, you get 5. So that's why 4 times 5, we get 20. Plus 3 plus, sorry, 3a plus 2a square root 5 plus b. This is equals to 0. Okay, let me just combine it in a certain way and I'll explain why I do that. So I'm going to put 29 here. 20 plus 9 is 29. Then this 3a plus b, I put them together. And then the parts with square root 5, I'm going to put them together too. So I'm going to get 12 plus 2a times square root 5 equals to 0. Now this is where a bit of imagination or some of your more fundamental mathematical knowledge comes in. So why is this? Why do I say this is an interesting question? Because, right, you must remember that my colors don't work anymore. So this one, right, this one, 29 plus 3 plus 2ab, right, is an integer. It's rational, sorry. Because a and b themselves are integers, right? So integer plus integer is still an integer and they happen to be rational. Because 3 times a, right, whatever value of a is an integer, plus integer is still an integer, and plus 29, it's still an integer. Okay? This is also an integer. But 12 plus 2a times square root of 5, right, is actually irrational. Because square root of 5 is an irrational number, right? So even if 12 plus 2a is integer, even if this is an integer, we still won't have any, sorry, even if this is an integer, when you multiply it to square root 5, right, this is still an irrational number. Okay, so the leap you need to make here is that you must understand that because a and b are integers, a rational number plus an irrational number can give us 0. This will only happen when both the rational part and the irrational part are actually equals to 0. Why? Because this coefficient, if you kind of treat it as a coefficient, this factor in front of square root of 5, right, is an integer number, because a is an integer. So when we multiply it to square root of 5, it's actually still irrational, you see, which means the only way for this equation to be equals to 0 is if the rational parts and the irrational parts are both equals to 0. Okay, that's a very key thing that everyone needs to understand here. Yeah. So I'm going to write down 12 plus 2a is actually equals to 0. Because why I was saying, right, the coefficient, if you want to treat it as such, of square root of 5 must be 0. Because we know square root of 5 is obviously not 0, right? So we must have something 0 multiplied by square root of 5 to give us 0. So 2a is negative 12, a is equals to 6. Sorry, negative 6. Right? So that's one of your answers. And also, applying the same logic, right? 29 plus 3a plus b must also be equals to 0. So 29 minus 18 plus b equals to 0. B is 9, is that correct? Let me see. No, 11, negative 11, yes. Okay? Those are your two values for A and of B. See here? Find the value of A and of B. So that's it. So, I mean, the important leap you need to make here, right, is to understand that this is a rational number plus an irrational number and it gives us 0. And the only way for this to be true is if both the rational and irrational parts are equals to 0. Okay? Beautiful question, actually. Okay, so 3 marks down also. We've earned 3 marks again. So then we have the rectangle of length 6 plus square root 12 has an area of this. Without using a calculator, find the breadth of the rectangle in the form c plus d square root of 3, where these are integers. So, this is actually a typical question. Nothing to be worried about. Because the rectangle is length times breadth, right? So, if you want to find the breadth of the rectangle, right? So part B, breadth is actually equals to the area divided by the length, right? So straight away you can write this down, don't need to waste time. 24 plus square root 48 divided by the 6 plus square root 12. Okay? So for me, I don't want to, I don't wish to simplify the surd here because I'm comfortable with the numbers. My first step I'm going to do is to rationalize this. Rationalize meaning you multiply by the conjugate of the denominator. So if you have 6 plus square root 12, we multiply by 6 minus square root 12 over 6 minus square root 12 so that we can make the denominator rational. So 6 plus square root 12, right? A plus b times a minus b. So it's a square minus b square. So square root 12 is just square it, right? You get 12. So far, so good. Then on top, right, 24 times 6 is 144. Then this is 24 square root 12 plus 6 square root 48. Then the final number is a bit big, but not to worry. Minus square root of 576. Okay, so this is our entire thing. So all we have left to do, right, is just to simplify everything. So what do I mean by simplify? Of course, denominator is obvious. It's easy to see. 144. It doesn't look like it has any friend now, but not to worry. Minus square root 576. So what I'm going to tell you might surprise you, but actually you should press your calculator for this. Minus 24. But wait, didn't the question say you cannot use calculator? No. What the question meant was you shouldn't use the calculator to do this division to get the final answer. Because the calculators that are approved for use in O levels, right, they will not give you this nice form. Okay? So because they want you to get this nice form, where C and D are integers, they tell you not to use the calculator. But in your intermediate calculations, right, it's actually perfectly fine to use the calculator. Or at least that's what I think. Okay, so square root 576 is negative 24. So this minus 24 square root 12 plus 6 square root 48. They don't look like they have anything common, but actually they do. So let me just write down minus 24 first. This square root 12, right, is actually square root of 3 times 4. So square root of 12 is actually square root 3 times 4. Which equals to square root 3, square root 4, 2 square root 3. Okay? So please do the same for 48. You realize that this is plus 6 times 4 square root 3. Nice. So this one, so now we can do the simplification, right? Shouldn't be too difficult. 144 minus 24, 120. Minus 24 times 2 minus 48 plus 24. So I'm going to get minus 24 square root 3. This whole thing is over 24. 120 divided by 24, 5. Negative 24 divided by 24 is just 1. So the breadth in cm, right? This is your final answer. This should be good enough for 3 marks, and the presentation should be no problem. Okay? So where c and d are integers, they didn't ask you to specify the value of a and of b. They just want to see it in this final form. So our final answer is perfectly fine. Okay? So that's it from me. If you found this video useful, please like and share and subscribe. And please tell all your friends about me. And as always, have a kitty nice day. Stay safe and work hard. Thank you.